Why nuclei are so tight? Why can several positively charged protons sit packed in one tiny nucleus and not blast apart, when like charges repel is supposed to be a basic rule? In energy filament theory, or EFT, the answer is not because nuclear force is huge, but because a new kind of slope appears when protons get very close. First, remember what a proton is in EFT. It is three quark rings with crooked straight textures that lock together. Their three texture bridges pull the outer side of the composite tight and leave the inside looser. Tight outside, loose inside, that's what shows up as positive charge. Far away, only this static straight texture matters. Two protons see each other as outward pushing patterns. Their straight textures crash, and the energy sea builds a slope that pushes them apart. That slope is the familiar electric repulsion. But as you push the protons closer, the picture changes. The static straight textures start to interfere and cancel in some directions. That gives room for a second layer of structure to take over, the dynamic spiral textures built from spin, magnetic moment, and phase. Normally these patterns only matter at very short range. Close enough, they suddenly become loud. If the spiral textures of two nearby protons happen to line up in direction and beat, something important happens. Between them, the energy sea lays down a smoother texture corridor, a route where the pattern is more regular and less strained than around the sides. A smoother corridor means a slope from rough road to easy road, and slope is what we experience as force. In this case, the easy road points toward each other, so the two protons are not pulled together by an invisible hand. They simply slide down a texture slope that happens to run inward. We call that nuclear attraction. So the rule becomes: far distance, static straight texture dominates, repulsive slope. Near distance, aligned spiral texture dominates, attractive slope. Whichever slope is stronger is the force you see. Now add neutrons. A neutron has no net charge, but its internal rings still carry spiral texture. In a nucleus, neutrons help the spins and phases of nearby protons line up more easily. That makes the shared texture corridors smoother and lowers the overall tension. The neutron is not just filler. It is a tuner that helps the whole nucleus settle into a deeper low-cost valley. So atomic nuclei are tight not because some mysterious glue yanks everything inward, but because, at short range, texture slopes change sign. Static patterns lose, spiral patterns win, neutrons tune the whole cluster, and the nucleus falls into the arrangement where everyone together spends the least effort. Tap follow, share it on New Physics, Clear Universe.